All right, we got a few folks still coming in. Thank you very much. Yep. Good afternoon, everybody. Thanks for coming. CON203, the future of Kubernetes at AWS. My name is Nathan Tabor, and I lead the product team for Kubernetes at AWS, which is why we're all here today. Really excited. I'm joined today by two very special guests. Alex Dimitri is the Director of Engineering at Slack, and Nova Dasarma is the systems lead at Anthropic. So really looking forward to what they have to say, and we have a great talk prepared for you guys. Let's talk a little bit about that. What are we going to talk about? What's our agenda? How do we even begin talking about the future of something that's moving so quickly and has impacted all of us so much? So at AWS, we're always looking at like, what should we do next? And I spend most of my time thinking about what we should do next. So in some ways, once we kind of decide to do something, in my mind, I've almost like shipped it sometimes. So I look back like 6 months, I'm like, oh, we actually shipped that. And so my head is constantly kind of thinking ahead, like, what are we going to do in 6 months? What are we going to do in a year? What are we going to do in 2 years? And it's really hard because sometimes those things are changing around. It's hard to put that up on a slide that's going to go on a video at reInvent that somebody will come back to in 2 years and say, well, you said that you were going to do that thing, and you didn't actually do it. And so I don't want to get in trouble, but I also want to give you a bit of insight into how we're thinking about things. Like, what are we thinking about, and what are we seeing, and how do we see the world, and how are we going to lay that out and put the pieces together? And hopefully, through this talk, you'll get a few hints about where our heads are and how we're thinking about Kubernetes and how we're thinking about supporting customers better. And so, obviously, at Amazon, we are incredibly customer obsessed. There is very, very, very little that the Kubernetes team or most AWS teams have done that is not driven by customer demand. And so that's why we have Alex from Slack, why we have Nova from Anthropic today here, because to get a picture for where we're going, you have to listen to our customers. And you have to think about what do you need from AWS to go better and to go faster. And so we're going to have Slack talking about scaling applications. We're going to have Anthropic talking about how they scale AI in a safe manner. And then I'm going to talk about three things, kind of the past, the present, and the future, that hopefully give you an idea of how we're thinking about what we're building and where we're going and the things that we're thinking about. So let's jump in. To get us started, the starting place is that Kubernetes is incredibly popular. To say it's a runaway success would be an understatement. The Cloud Native Computing Foundation, which is the governance organization for Kubernetes, they did a survey. And last year, their survey said that 64% of enterprise organizations were using Kubernetes in production. And an additional 25% of those organizations were evaluating or piloting Kubernetes. So that's a plurality of organizations looking at putting Kubernetes in as part of their business, making it a core part of how they run applications. And so why do people use this thing? Like, this is this open source technology. It's complicated to run. It has some really quirky little features that go along with it. If you've used it, and I think many of you have, you've run into some of these weird things, right? But there's very good reasons. And so when we talk to our customers, we see 4 reasons why people use Kubernetes. And the first is to have better innovation, to innovate on behalf of their customers. And how do you innovate? You innovate by moving quickly. And being able to make changes safely and rapidly, that's the most important thing. And you're able to make those changes when you have systems and standards for how all your development teams make those changes. And so that's the first big reason why we see customers using Kubernetes. The second reason is to reduce fixed expense, to go from using static resources and doing things like one process per VM down to dynamic shared resources using containers. So breaking things up, eliminating complex contracts, eliminating management overhead, lowering their costs. And the third reason is to enable the entire organization. So Kubernetes provides this API standard, right, for orchestrating applications. And so customers want to say, hey, whether I'm running in different regions in the AWS cloud, whether I have some workloads that are still on-prem, and whether I have, oh, we shouldn't say this too loud, other clouds. I know, it's reInvent, right? But it happens, right? There are workloads that run in lots of different places, and it's really convenient to have a standard that lets you run across all of those places in a consistent manner and establish best practices and governance controls and security and monitoring and cost management and all these complex things, and to have them work no matter where you run, or even if you're all in on AWS, and I love AWS, I'm all in on AWS, obviously, but then you go out and you acquire this company, or there's a merger, and suddenly you're a systems lead, and you have to manage this other team that's running in this other environment. How do you do that, right? So Kubernetes lets us take care of thinking about that cross-environment standardization, and also planning for the future and reducing our risk. And that's really important. And reducing risk is not just a thing that CIOs and CTOs and big wigs that fly on the corporate jet think about. Risk is something that engineers think about, and it's something that development leads and development teams think about it. We just usually call it tech debt. And so that's the big thing as well for Kubernetes, is helping to reduce that tech debt. And at AWS, we've invested a lot in Kubernetes. So EKS is celebrating its 5th birthday this June, 5th year of being generally available. I'm really happy to say I was here in reInvent 2017. We announced EKS for the first time. That was really an exciting moment. And over the last 5 years, we've invested significantly in EKS to have it represent the best of AWS: performance, scale, reliability, and availability. And that's why when we've talked to the CNCF, when we've looked at our customers who have this data, they tell us that more Kubernetes workloads run on AWS than any other place. And that when we look at our data, we see that billions of EC2 instance hours are being run with EKS every single week. And that's incredible, because I remember when we launched this thing, it was just this little scrappy service, and we were gonna help customers run Kubernetes control planes better, and then to turn around and have literally billions of EC2 instance hours, that's an incredible thing. And what are those customers doing? They're doing everything you could possibly imagine, from moving legacy .NET and Java apps over to the cloud, doing data processing, building real-time backends, building web front ends, and recently, machine learning and AI ML has emerged as a major use case for EKS and Kubernetes. Everything from generative AI, robotics, and personally, I'm a big fan of autonomous vehicles. I think they're really, really cool. And we have a lot of AV training going on in EKS right now. It's really cool to see companies that are kind of working on the future technologies, right, with machine learning, and all of those different tools, all the KubeRay and Spark and Kubeflow and all those things running on EKS. But the thing that we look at as a team is not just the use cases, it's not just the applications of where Kubernetes is running, it's where does it run in the stack and what are customers doing. And this is an important one if you want to think about how we're thinking about what we do for customers. How do we remove that undifferentiated heavy lifting? So we're looking at, there's infrastructure, and then we're looking at how Kubernetes is sitting on top of that, helping to orchestrate across that different infrastructure and knit all that together. And then customers are bringing deployment, observability, governance, traffic controls, security controls, all sorts of things that they're layering on top of Kubernetes. Now, a lot of these run inside Kubernetes, and actually, if you look at the CNCF, there are 599 open source catalog projects that either run in or next to Kubernetes in the CNCF. 173 of those which are actually open governance and run directly by the CNCF. That's a lot of stuff to run this platform layer on top of Kubernetes. And in addition to that, we're building a whole bunch of integrations from AWS to allow AWS services to provide some of these capabilities into Kubernetes. And then if you go up one more layer, you have this IDP, this integrated developer platform. This is, how do I take that application, how do I package it and run it on Kubernetes with that deployment, observability, governance, et cetera? How do I orchestrate my data processing jobs? How do I orchestrate my machine learning workflows, right? So this is the different layers that we see customers using, packaging in containers and then running on this stack. And this is the thing that we're thinking about, is how do we help customers do this a little bit better? And there's 3 goals that we have for helping customers run Kubernetes on AWS: to take away undifferentiated heavy lifting, to simplify things, to give you complete access to the scale, stability, and security of the cloud, and then also to ensure that we perpetrate that standard, that open source standard of Kubernetes, ensuring compatibility with those 599 CNCF projects, allowing you rapid innovation, access to new innovations from the community, from partners, and to also perpetrate and improve those community standards. And so overall, the goal is to allow you to focus on your expertise, to build reliable systems at scale, and to lower your risk profile. And EKS is one of the ways, it's probably the kind of that pinnacle way that you see AWS supporting Kubernetes, but there's a lot of other ways too. EKS would kind of fall into that management bucket, right? Like it's how we manage Kubernetes for customers. We also have a distribution of Kubernetes. We build a number of integrations. I think we looked at, there's 20-something open source projects that allow you to integrate Kubernetes with parts of AWS, everything from CSI drivers to CNI to load balancer controller to ACK. We also develop upstream. We push code and we do development with upstream. We provide security assistance for the entire CNCF and for the Kubernetes project. We sit on the Security Council and we review issues and critical vulnerabilities and help with those embargoed issues to make sure customers are safe, whether they're on AWS or running Kubernetes somewhere else. And then we also provide direct sponsorship. We provide funding to the communities to help people build their projects, and we help them build systems that help lower costs and improve availability of community projects to everybody. And so EKS being the main thing, we have EKS and we have EKS running everywhere at this point. We have our distro, we have EKS Anywhere, which is a tool chain for running Kubernetes on premises, and then EKS is now running on Snow, Outposts, local zones, wavelengths, and of course, in the AWS region. And the goal is that if you want consistent performant Kubernetes, we have an option for wherever you're gonna run that. And I don't even know if I can tackle this slide. There's so much. I was looking back. I just wanted to share how much development has gone into this product over the last 5 years. We counted, I think there's a little over 222 different launches that we've done since we announced EKS in 2018. Everything from reducing our price to compliance to launching new projects and accelerating cluster creation time, adding new instance and region support, and new critical features. So I'm going to turn the mic over now to Alex from Slack, and he's going to talk about how Slack is using EKS to develop their systems at scale.
Engineering. Oh, now it works. I'm a director of engineering at Slack, and I have the pleasure of leading several teams that are obsessed and passionate of making our internal customers happy, so much so that Amazon wants to make their customer happy. Same is for us. We're a core infrastructure team, and we want to make our internal customers happy. So we specialize in scalable and reliable compute infrastructure, and we partner with AWS and with EKS closely in a journey that I'm going to walk you through on how we went from some of the challenges that we had to where we are today. So back a couple of years, we mostly were running an infrastructure based on virtual machines with Chef as configuration management. Operating these systems and operating systems upgrades were very costly for our customers. Our internal customers were going through a lot of toil to try to do these operating systems upgrade, or when we proudly introduced our offering for GovSlack last year, also this increased the amount of toil that our internal customers would have to embark on for managing their VMs. So we started asking ourselves, what could be a good solution that is going to take us and it's going to take Slack's application, allow our developers to test more accurately, and just having much more scalability and flexibility in our environments. So we looked at Amazon EKS, and going back to some of the problems that we were having, Slack was having infrastructure complexities, and we were causing some issues, mainly based on some of our configuration management problems. We had, with Chef, it was a monolithical experience for our developers with their infrastructure as code, and some of these changes were really hard to test. And so like for our developers to be able to test accurately their code and have confidence, sometimes they would just ship code out because the testing was not as solid. And so with that, we started asking ourselves, what is the platform that we're going to put together with EKS that is going to abstract a lot of the complexity while maintaining some of the reliability and scalability concerns and problems that we want to resolve. And so this created what we call Bedrock. So if I were to give you an elevator pitch, like what is Bedrock? Bedrock is basically a platform as a service that behind the scene leverages Amazon EKS. It handles your build, your deploy, and runtime environment, and our awesome team of engineers that are in the room today are the ones responsible for building these incredible abstractions that allow to have a Bedrock API that we refer to as BAPI, and also a runtime environment and a Golang library. So some of the functions that you see there is how the life cycle of a container for your application is going to come to life. One of the biggest problems we want to sell, or what we want to do for our customers, is we want you to be able to take your ideas from where they are, the ideas, to production without worrying about a set of other infrastructure complexity or networking, et cetera, et cetera. And our promise is that all of that, we're going to do it powered by a single YAML. So this is the user interface. This obviously is a little bit of a simpler file, but this is what one of our internal developers would be presented on to launch either a new application or converting an application that was running previously on VMs into Bedrock. So we have images, Docker files, a call out there for our clusters. We run our own clusters to be compliant with our software-defined firewall called Nebula. It's important for us to run our EC2 nodes for our Kubernetes nodes. So we have our team that it creates a better, and we'll see later with Carpenter, procedure on how to create these clusters and maintain these EC2 nodes. So as I said, simply enough for a developer, they need to specify ports that they want to open to our secure shared VPC network in compliance with our software-defined firewall, Nebula. And then it just takes a bit to just list out on console, what is your service, how is your service going to be discovered. And you can see there that it's relatively readable and simple to use. So where is the magic that happens in all this? Files will be longer depending on our application. This simple 17-line YAML file is translated into building Docker images, publishing them to the registry, and then out of there, Jenkins kicks in. We have a pipeline, and the deployment goes out. Your container goes to a specific cluster, and then it registers itself in our service discovery solution, FQDN, and you're good to go. So with that, also I wanted to add, recently we were also able to templatize this specific YAML file, which provides a lot more flexibility from team and less maintenance overhead. So again, if we take a little bit of a look under the hood, what does this look like? So on the top, you see several boxes which make up other teams and applications in Slack that are critical for this to work. But part of what we want to make for our product engineers, for our internal customer, what we want to make simpler is that we want to abstract a lot of this. I want to make simple systems for them to still scale, to be efficient, and not having to worry about making all of this work. So we have console, as I said, Uber proxy for FQDN resolution, Nebula software-defined firewall, which allows you to communicate with other systems in Slack. And this is where it gets critical for Bedrock to allow developers to test with accuracy and with confidence, is with having a plug directly into Slack's ecosystem. Your tests are going to be accurate and going to be actual. And so this, together with Ops Jenkins, is the top part of what makes this happen. So Grafana and Prometheus are the tools that we're also using for monitoring and visibility and make sure that we have observability in our applications. And then, as I said, the Bedrock CLI and the Bedrock API that was developed in-house by our developers team, our infrastructure developers in my teams. So with this, also we have Kube Beaches, which are SSHable VMs that allows our customers that maybe we have a set of customers that want to be more power user and want to be able to do more tasks and manipulate EKS, or they have the knowledge or the desire to do so, and they can do that in a controlled environment that it's safe and it's still not sacrificing any of our zero trust network policy. One call out there, as I said, the API, and then we have Carpenter for our node management. So Carpenter is actually being one of the tools that we're being very excited about and we highly recommend. We've partnered with this with AWS, and we onboarded it into our clusters, and it's been a great success. What you see there, it's a little bit of our stack and how we end up essentially provisioning new nodes that go into these Kubernetes clusters. We start with Chef, which still remains our configuration management, and then our service called Pop-Tart, which is another in-house service that goes and provisions these nodes. All of this is also kind of Slack Ops-ified, as like a lot of this process you can notice in your channel. You can see what happens, how your node gets provisioned, if there's any failure or something like that. So with that, all of our nodes are considered immutable all the time, and we don't allow a node to live longer than 14 days. And we're able to do that with service annotations that manage the life of the nodes, as well as like also integrating, thanks to this and Carpenter, a set of chaos engineering and like tooling that allows us to feel more confident in case of an outage. So speaking of that, what are the benefits that we're getting out of Carpenter, for instance? So the dynamic nature of Carpenter itself and the way that Carpenter is able to have dynamically allocating nodes based on pod resource requirements have made us being able to have better bin pack clusters, and at the same time also, as I'm sure as it is for a lot of you, we have been able to be a lot more right-sized and in the past year to save a lot more money on our AWS bill. No more incidents or awkward incidents, I should say, in certain cases where like somebody takes down a cluster or there's like modifications in the auto-scaling group, in Terraform files. With the nature, the dynamic nature of Carpenter, we don't have to deal with these issues anymore. So with that, faster node drain, faster provisioning, rotation, and quicker recovery in case of incidents. Like I mentioned, if in case a cluster gets nuked or some issue, we're almost able to bring it back in seconds or minutes instead of other timelines when we had difficult situations with EC2 VMs, et cetera, et cetera. Carpenter is also really fast as it plugs in directly into EC2 APIs. And yeah, as long as AWS has capacities, our applications can scale, and we can respond to our external customer requirements and our internal customers and whatever they need from our core infrastructure development perspective. So again, one more look on cluster upgrades. This is how we manage our Kubernetes clusters. Kubernetes has a very fast version upgrade schedule, as much as EKS is also releasing a lot of new features. So we always want to be on the latest features so that we can offer the best feature to our internal customers to develop their applications. So with this, we have the release notes. We go through kubelet and kubectl. Our team internally has done a phenomenal job to do these upgrades with like zero impact to our customers. And we locate the versions. We go through a specific soaking period so that like we verify with a 10, 25, 50, and 100% rollout per environment to make sure everything is okay. We follow this through Sandbox, Canary, Dev, and Prod, and it also gives us a lot of confidence in case we need to do some rollbacks. So where we are now. So this project started, and we're very proud about it. This has been the result of a lot of effort from our internal engineers. A huge shout out to also our TPMs that are being part of this process with us. And you can see from the numbers, like how much, like we can't even count the memory really. Like we tried, but that's pretty much what we got. But in general, at this point, I'm proud to say that 80% of Slack applications run now on Bedrock and Amazon EKS, and they can take advantage of all of the great features that you're also gonna hear about today. So for us, personal wins, not just from like an infrastructural point of view, but for our internal customers. Now your infrastructure as code lives in your repo, just like the rest of your infrastructure. And so like you don't have that monolithical approach you had before, but you have a lot more flexibility from that point of view. AZ rebalancing and AZ draining, zonal resilience for us is a lot easier with Bedrock and with EKS. And this is part of also what powers our disaster recovery strategy for certain aspects. The other big shout out is like I said, we launched Glove Slack. It's been a great effort, and part of this was creating compliance across the board. And so for each service owner to go and profile their applications and their VM with AppArmor was a lot of toil and a lot of effort. And we abstracted that by profiling with AppArmor all the Kubernetes infrastructure. And again, to what we were saying earlier, they can just focus on writing code in their application. As a final shout out, again, on the FinOps side and on the fact that it's really important for everyone at this point to be as efficient as possible, with Bedrock, we were able to also plug in a KubeCost, which has been a phenomenal tool to use. And with that, creating a Bedrock chargeback model so that every service owner is able to see what they're spending, how they're spending, where they're spending, and we can all run more efficiently. And so with that, I'm going to pass it back to Nathan.
Very much, Alex.
Thank you.
Cool. This is great. Bedrock, that's an amazing system. Thank you. So Alex talks a lot about how do you build on top of Kubernetes. And one of the biggest things that we've been working on with EKS to help customers build on top of Kubernetes is where is this available? And I talked a little earlier about, we can run in regions, we can run on outposts and local zones. And I thought this map was really incredible. We are now have EKS available in every single AWS region. And we actually were in our first region at launch this year, which was Tel Aviv, so it's super exciting, and there's more of that to come. And because we have 5 regions that have been announced now by AWS, and EKS will be in every single one of them. And today you can run EKS in 32 regions, 102 availability zones, 33 local zones, 29 wavelength zones. So almost anywhere in the world, if you need to get close to your customers, you can put an EKS cluster in that location. And if these locations aren't good enough, then you have outposts, and then you have EKS anywhere. So you can get right down to the edge with EKS. So we're really excited to have EKS so available in all these different places. And I'm going to spend the next few minutes, talking about what I told you I was going to talk about, which is what are some of the big things we've been doing, and you can be thinking about, well, what are the things that we're going to build next from these different innovations? And so, like I said, EKS Anywhere, if all those cloud regions aren't enough, we've been expanding the footprint and the capabilities of EKS Anywhere. It's now supported and shipping with Snow devices. So Snow, which started with just storage, has now expanded to be edge compute, and EKS Anywhere ships with all Snow devices. You can also provision bare metal nodes on your own infrastructure with EKS Anywhere. So you can use VMs, but you can now also use bare metal, and we have Tinkerbell provisioning built in. And then also, one of the challenges customers had was subscribing to EKS Anywhere. Previously, it was a pretty manual process. You had to call us up. That's not really how AWS likes to do things, is having us call you, having people have to call up. That's inconvenient. So you now can subscribe to EKS Anywhere directly in the EKS console. So nice little usability. And in addition to regions, versions are incredibly important. Alex was mentioning how Slack likes to stay on the latest versions. And I have to admit, a year ago, EKS, we were a little bit behind. So we were shipping new versions about 240, 250 days from upstream. And it was really slow. And customers said, hey, we want access to the latest and greatest stuff. So we took a big push this year, and we've moved our upstream lag from 243 to 42 days over the last 4 versions. We launched 4 versions this year to catch up with Kubernetes, and we built a whole new automation suite internally that lets us qualify and roll out new versions. And I promise you, this is probably the only time where a graph that's going down, that's actually a good thing. That's good. My team wanted me to put that there because they said, usually you want graphs going up and to the right, right? So this one's actually good. This was really good for the latest stuff, but it created this whole new set of problems, right? Because now, and you may have encountered this, you have to move off and you have to upgrade to these latest versions. And a lot of customers told us that 14 months of support just wasn't enough to get to the next versions. And so in October, we announced extended support for Amazon EKS, which allows you to run any Kubernetes version starting with 1.23 up to 26 months with full support from AWS. You can create clusters, you can upgrade at any time to any of these versions in extended support, and we provide security patching for the control plane, for the components, and for the AMIs. So we're really excited for this. This is now available as a free preview in version 1.23. We'll be going GA with this solution in early 2024 for 1.23 and higher. So this is available right now. It'll continue to be available for all future versions of EKS, and we're really excited about it because it gives customers just that little extra time. And the goal here, when we talk to our customers, is that you should be able to launch a new Kubernetes version 1 time per year as a customer. So a lot of people have told us we want to upgrade once per year. So looking at how much time people need, if that takes an extra 3 months, 4 months, 6 months to do, the goal is to allow you to upgrade once per year. And we'll talk a little bit about what else we're going to be doing to allow you to upgrade 1 time per year. But one of the things that people also told us was, hey, we're good at running our applications, and we can spin up that EKS cluster, and we can add things in. But when it comes time to do that upgrade, we have 200 clusters, and we don't have the automation. We literally don't have the staff that can come in and do this work for us. And so we worked with the AWS Managed Services team, and they put together this Accelerate program, which they just announced, I think 2 weeks ago. The AMS Accelerate for EKS provides hands-on SRE resources to do certain tasks that can help you move quickly and to do those operational things that you may not have the number of people or the expertise to do at scale. And so they help with observability, setup and management, They'll do hands-on keyboard incident response, and they'll also do operations on demand, like cluster upgrades. So this is a really exciting offering from AWS. I think that the people who need this will get a lot of value out of it, and we're excited to partner with those teams to give that extra support if you do need that. Okay, let's talk a little bit about security. And I think we had a big focus this year on security on the EKS team, and I want to talk about a few of the things that we've been doing to improve security. So first up is AWS Pod Identity. This is just launched. This is a new launch yesterday. Really excited to introduce Pod Identity. And what Pod Identity does is it leverages the pattern for how do I get IAM roles into my Kubernetes applications? How do I give that pod access to other AWS resources using AWS IAM roles? So we've had a solution for this for a few years. You may have heard of it, called IAM roles for service accounts. And IAM roles for service accounts works really well. It's an architecture. You stand up this OIDC provider endpoint, and you write all these trust policies, and then you write a role for every single pod you want to connect to everything else in, oh my gosh, like you will end up with hundreds and hundreds of roles. So it works really well, but it starts to break down its scale. And customers found it hard to scale this and to deal with all the IAM roles and to create OIDC providers. So Pod Identity, we're improving this feature and we're building it more deeply into EKS. So we actually own and vend the credentials from the EKS service without you having to stand up an OIDC provider. We allow you to just walk into EKS. We have the context on what role needs to be vended to what place. And so you can map all the roles that you need for your clusters and for your applications centrally, so you don't have to annotate YAML files, you don't have to create multiple trust policies, you don't have to duplicate roles across clusters, and we're able to add things like session tag support, which means that you can have dynamic roles. So very basic roles that says, give this application access to an S3 bucket. Which S3 bucket, we're not sure. But with session tags, I can say, well, this cluster is tagged with prod. And so it gets access to prod S3 buckets. And this cluster is tagged with dev. So it gets access to dev S3 buckets. And so session tag support allow you to have security, but tag-based authorization along with your IAM roles and with flowing down to the EKS cluster. So overall, it makes it easier to add IAM to all of your Kubernetes applications and simplifies the setup and configuration. So that's IAM out of the cluster. How do I use IAM to get out of the cluster? And the other thing that customers have asked us to improve is how do I get IAM into the cluster? And so we're getting ready to announce and launch a feature called Cluster Access Management. This will be coming soon, likely in 2023. And this allows you to use the EKS APIs to manage all the different IAM role mappings into your cluster. So we're removing the AWS auth config map and allowing you to configure all the RBAC permissions inside of the cluster using the EKS APIs. I'm super excited about this feature. It's going to unlock a bunch of really cool possibilities. And the team was so excited about it, they wanted me to talk about it today at reInvent. So you're getting a sneak preview of what we're going to be launching really soon here. And I think this is going to be really nice, improving the usability of EKS. Talking also about security is the VPC CNI network policy. So network policies are really important for traffic control and routing management, allowing certain pods to talk to other pods inside of the cluster. And previously, you have to install an agent. You have to install Cilium or Calico or something else into the cluster to actually implement network policies. So what we did this year is we added that natively into the VPC CNI. We built an eBPF data plane to do this. Another hint, I'm just calling out the hints here for what could AWS be up to in the future. We built an eBPF data plane into the VPC CNI. And we used that data plane. The first function that we did with it was to actually allow it to implement the VPC or the Kubernetes network policies. So you define the native Kubernetes policy. It's already included in the VPC CNI. We implement that policy for you for all the traffic in the pods. And this is included. There's no additional agents to run or configure or scale. It's integrated with VPC security groups. This is GA right now. We launched this earlier in the year. Really excited about this feature. Talking about integrations and connecting things, we talked a little bit about, we have all these things. We have these 599 things that can run in the cluster. And you're also at reInvent, right? So you're walking around, you're like, wow, there's also like 200 plus AWS services and new services that are being announced. I wish I could use that more easily with Kubernetes. I want to use Kubernetes to provision that database. I want to use Kubernetes to provision that storage bucket or provision this other AWS resource. And so AWS controllers for Kubernetes is a set of CRDs, a set of controllers that allows you to use the Kubernetes API to provision and manage other AWS resources. And this is really useful because you may want to use SQS with your Kubernetes application. You might want to have a queue implemented by AWS that's sending different data down into your cluster. But what you may not want to do is use CloudFormation or Terraform to set up all those AWS things, then go into the cluster and set up all those cluster things, and then wire that all together. That's really complicated. And with ACK, you can actually do that natively. When you define your Helm chart, you can just define, I want this resource from AWS to also be defined, and you can natively connect the endpoints and the values for those different resources directly in Kubernetes. So super excited. We have 21 GA services supported with ACK right now. We have 11 more in preview, and we recently added 3 new services, Event Bridge, SQS, and SNS. So this one will keep going. We're super excited about this project. In addition to ACK, there's a bunch of auxiliary things, and actually there's a survey stat I didn't put here, but when I was looking at that survey, around 60% of the things that customers run in their clusters are what we call auxiliary workloads. They're add-ons. They're things that help you run your applications. And we built EKS add-ons to make it easier for customers to bring all the different things, all the different components into the cluster, to start the cluster and to lifecycle manage, so to do simpler upgrades. Add-ons has been okay, and we're making some improvements to it. So this year we added what I think are some really critical improvements, and they're really unlocking the power of this feature and the vision of it. So you can now configure add-ons before launch. So you can add custom values into those charts when an add-on launches directly through the EKS APIs. And we also, last year at reInvent, we announced an integration with the marketplace. AWS Marketplace, and you can start vendor add-ons directly on the cluster. And we added the ability to subscribe to those add-ons. So whether it's a free or a paid subscription, you can now subscribe to those add-ons directly through the EKS APIs and the EKS console. And then we expanded the catalog because add-ons works when there's a really big catalog. So we added this EFS CSI driver, the GuardDuty agent, and we doubled the number of marketplace add-ons that are supported. And in addition to the add-ons, we also added a whole bunch of capabilities for observability. So CloudWatch announced an entire new observability suite called Enhanced CloudWatch Observability just for containers and EKS. It gives you complete container-level performance metrics, cluster-level performance metrics, logging, a full cluster dashboard, and lets you have predefined alerts and alarming and drill down all the way through the cluster. It's super cool. They launched a new agent that's also a new add-on and is available right now. And they launched this 2 weeks ago. Really nice product, worth checking out. At the same time, we have a new launch, and I should have put a tag closer to this, the Agentless Prometheus Metrics Collection. This just launched last night here at reInvent. We're really excited for this. If you're using Prometheus, if you're using AWS Managed Service for Prometheus, we can now collect Prometheus metrics in an agentless way, completely serverless inside of the cluster, and we can export them to AMP. It works for any cluster. You enable it in a single click. It scales with your cluster, it scales with your applications, and it's natively integrated with AMP. So super cool launch. I know the AMP team will be talking about it this week. We're really excited to partner with them and have this be available. Alex mentioned Carpenter. Carpenter is our auto-provisioning system for compute and for nodes. We added a bunch of features to Carpenter. The most important thing to talk about is that we gave Carpenter away to SIG autoscaling. So we're really excited that Carpenter is now part of the CNCF. It's actually part of the Kubernetes project. And at the same time that we did that, we had Azure announce, I know we're at reInvent and I'm talking about Azure. What's going on? Like, are you at the right conference? But we're really excited about this. We've seen a lot of customers have success. We've seen customers lower the amount of nodes that they're running on their clusters by 25 to 40% using Carpenter. And we think this project is going to be this gold standard for node autoscaling in the future. And so going into the CNCF is a huge part of that, allowing this to become part of Kubernetes. And then also having other companies like Azure build providers for this, it gives customers, and it should give you extra assurance, this is here for the long run, this is the way to go. And we're super excited to see that community growth with Carpenter. And then what would a talk be without machine learning? Machine learning is, like I said, one of our fastest growing emerging use cases, and we've been investing a lot to make machine learning easier on EKS. So adding the latest NVIDIA and Neuron drivers, adding P5 support, adding drivers for EFA, which is Elastic Fabric Adapter on EC2, and also support for capacity block reservations. We're really cool to be seeing how machine learning is taking off. And so to give you a little bit of insight into how companies are using EKS for machine learning, I have Nova Dasharma from Anthropic.
Thanks, Nathan. So I think some folks may have heard of Anthropic. We're an AI safety and research company. We are building reliable, interpretable, and steerable AI systems. Like Claude, we've launched 2.1 pretty recently, and our mission is talking about frontier systems, responsible deployment, and regularly sharing those safety insights. And we do this with EKS. All of our applications, from training to data to inference, all of these run on top of Kubernetes. In our training, we scale to tens of thousands of pods and individual objects inside of Kubernetes. We utilize flexible instance types as part of our data workloads. And we utilize Carpenter, as other folks have talked about today, for some of those cost optimizations, as well as increasing utilization of the infrastructure that we want to use anyways. And I'm also going to talk a little bit about how you can integrate EKS and S3 to move your state out of Kubernetes and let Kubernetes take care of the scaling of the application, and S3 holding on to that static state. So, like, how do you train an LLM today? So, gonna give you a quick diagram. I ran out of time preparing these slides, and so I got Claude to write this for us. We just released function calling, and so we put all our Terraform in there, and this is what came out. So I'm gonna explain that. So the process goes from raw data that we get from scrapes and from other sources, and we use Carpenter to provision Spot EC2 instances for both Dask and Spark workloads. All of those are on EKS, taking data from those raw data buckets, tokenizing that, bringing it back into tokenization buckets in S3, and then back from there to accelerated EC2 instances like P4Ds, the new P5s, and Trainium instances as well. And those are all inside of EKS. We then utilize S3 again. You can see this sort of weaving back and forth. From S3 to EKS here to store our model checkpoints. We actually don't use PVs for those because we find that we can get enough performance directly out of S3, which is pretty exciting. To talk a little bit more about that data processing, we use multiple instance classes. Historically, we would use cluster autoscaler, and we would put together, an R5 instance group or something like that for our specific Spark jobs. And we found that oftentimes we would run out of capacity in a particular way, or we would want to scale something with a different ratio of CPU to memory. And Carpenter means that we can express those constraints in the way that we think about them and not have to think about the individual instance types. We're also able to use Spot, on-demand, and reserved instances together here, and that just helps optimize cost. And yeah, different data processing use cases mean that you might need more network in one case, more storage in another case, and Carpenter lets you do that. So we use that quite a bit. And yeah, here's the big number. So year over year, we had a 40% cost reduction over using on-demand instances by being able to utilize flexible instance types in Carpenter, as well as Spot instances more generally. We didn't talk about this on the slide, but yeah, no cluster autoscaler tweaking required. A cluster autoscaler can often get stuck in various ways, and Carpenter just doesn't do that. It stays snappy. You're always going to have your instances deprovisioned when you don't need them anymore, which is important and something that autoscaler has a hard time with sometimes. So it's quite helpful for our use cases. And yeah, so I've mentioned S3 here as well. It's nice to have a single source of truth for your applications, and for us, that's S3. We use S3 to store our data. We use it to store our checkpoints. We use it to store our evaluations. And not having to synchronize things down into PVs just lets us think about state in a much more abstract way and be able to scale the data and the application separately. We do this using asynchronous processing from S3, so we try to stay in this throughput bound regime and not worry that much about latency there. And yeah, it doesn't hurt that there's no more PB management in this world. We use PBs for a couple of things, things like scratch disks and stuff like that. But today, we're no longer blocked on the PB controller synchronizing, so that's pretty nice. And here are a couple of tips and tricks that we found while using EKS today. It's important to think simple first. We've managed to scale to training things like Claude, like I said, tens of thousands of nodes, tens of thousands of pods. Using stateful sets, we don't actually use CRDs for a lot of our workflows, and that's managed to scale out just fine for a lot of the things that we do. Optimize for preemption. You can't use spot instances if you're not thinking about your state separately from your application, and you can't take advantage of Kubernetes' ability to do things like scale out if you're not optimizing for your workloads being disrupted sometimes. As you scale, just thinking about training, everything bad happens at scale often, and so when you're training something, your nodes are going to go down. You need to be thinking about your application as a sort of state that you're working towards more than a thing that exists across some servers. I already talked about state management, and yeah, think async. You really want to be using S3 the way it wants to be used, and the way it wants to be used is in a throughput-bound regime. You can scale across multiple prefixes and things like that to get the performance you need. We don't need to have high-speed PBs attached to our machines today, specifically because we've architected our applications to preload data out of S3 and keep a nice buffer there. So we're able to maximize the input from those network cards. And I'll talk about that later this conference. And yeah, I think Nathan for some predictions for the future.
Awesome. Thank you, Nova. That's pretty cool. I mean, I think you're really underplaying how cool that system actually is. And you're right that everything can and will break at scale, so we have to design for that scale. I want to talk a little bit about where we see things going. How can we predict the future? Like what's in there and where are we going? How are we thinking about it? So 5 more years of EKS. I mean, hopefully EKS will be around, and I expect it to be around for much more than 5 more years, but we're celebrating 5 years today. So what about the next 5 years, and where are we going? I think we're going to see 3 things that AWS is going to be doing. More things are going to be managed. So taking an approach where what I like to call the cluster vending machine. And this is something that many of you may already be building, and we're also seeing many customers build this as well. And it could be a vending machine that spits out clusters that are used then directly by developers. It could be a vending machine that spits out clusters internally, and those clusters then are used by platform teams and abstracted higher up the stack. Either way, helping our customers more easily vend application-ready clusters. What are all those components that we need to bring together in order to build that cluster vending machine? Giving customers more support with upgrades, giving more automation around upgrades. I mentioned earlier that we're just getting started with extended version support. We have a whole bunch of things that are planned for 2024 and beyond around how can we help automate those upgrades? How can we help bring all the things together in the cluster, all the add-ons together in the cluster? How can we help you true up a cluster? If you're like me, and you don't go back and look at a cluster for another week or 2, and then you open it up and you open the console, or you do a kubectl and you look at the versions of things and you're like, oh my gosh, everything's out of date. How do I get this all up to date? It's a full-time job just keeping all those components up to date. Some of our customers are running 40, 50, 60 different things in every single EKS cluster. So how do we help true up those clusters? How do we give you confidence when you push that button to upgrade that things are going to work on the other side? That's a really important thing, and I think, if I had to predict, I would think there's going to be some stuff down the road. How do we give you more confidence to know that things are going to work after an upgrade? And then managing more compute, managing more components, helping to take away that heavy lifting. If you and everybody else that you talk to at reInvent is doing the same thing with EKS, then you can probably guess that we're thinking about how can we help you do that, because it may not be something that you need to do on your own. Second, more Kubernetes for AWS, the data center, and the edge. So building deep bidirectional integrations with the AWS cloud. We talked about some of those already today. Things like better integration with capacity block reservations and the different machine learning tools, better integration with IAM and with observability and networking tools. I'm really excited about, we didn't talk about it today, but our integration, for example, with AWS GuardDuty. GuardDuty provides threat insights across a number of clusters, and they announced runtime monitoring for EKS in January, February this year. And that's a really cool integration. It can take insights around different threat actors that are happening in one customer on one cluster in one part of the world, and it can generalize that threat and recognize it if it happens to another customer. And that's the kind of integration that you can turn on with a single click in AWS, and it goes into your cluster and gives you insights that you didn't have before. Those are the type of bidirectional integrations we're looking at for security, for governance, for improving developer productivity. Allowing customers to migrate workloads between clusters, migrate from on-cloud. Having services that help you to containerize things and to get efficiency out of systems that previously were monolithic and hard to run. And then having better hybrid node and cluster management. How can we help ease the burden of moving things from on-premises to the cloud? How can we recognize that some things are going to stay on premises? We have customers, and you may be one of them, that have things like trading floors that they need to operate on. How do we help you get a consistent management experience regardless of where you're running? And then having efficiency at scale. I talked about GuardDuty, coming in and recognizing threats, but we're thinking about how do we do that same thing for efficiency? How do we see patterns that work in one places and give you hints and ideas and suggestions to improve your efficiency? Applying those insights for cluster tuning, and then giving you centralized observability and troubleshooting and deep dives. And you see some of those innovations coming with CloudWatch and AMP are looking at how can we help customers monitor and troubleshoot their entire estate at scale. And then for machine learning, since this is such a big use case and we have so many customers rapidly adopting EKS and Kubernetes for machine learning, we have a deep roadmap of stuff that we're working on and that we're planned. All the way from new CSI drivers for NVMe and S3 mount points, the AL 2023 accelerated AMIs, and going all the way up to better tuning the control plane for large-scale machine learning workloads, giving you the latest NVIDIA and Neuron drivers, expanding the EKS add-on catalog with more machine learning tools and capabilities, and then giving you access to EC2 features like EFA, GPU time slicing, capacity block reservations, and savings plans. So there's a whole roadmap here for machine learning and helping customers to build models and to do training and inference at scale. Okay, but how do we actually predict the future? The best way to predict the future of what we're going to do is to look at what you're doing and what other customers are doing, and to see that we're going to be following everywhere that we see that there's undifferentiated heavy lifting, that we're doing things repeatedly, that we're building similar platforms. We're looking at how do we help you do that faster, how do we help you do that more reliably, and how do we help you do that efficiently. And a good way to give us feedback and to see what other people are looking to do is our EKS public roadmap. So on the roadmap, we have a number of things that we're tracking. You can submit issues, you can give us feedback and ask us what to do. I counted some stats for this. We've shipped over 408 EKS items on the roadmap since we started it. So we've shipped a lot off this roadmap, and we've had almost 850 total items created across all AWS container services that are tracked on this roadmap. So if you have an idea, if you want to see what other people are thinking about, if you want to collaborate with us on what we're building, and we've had a number of things where myself and our team were on there every single day, talking to customers, collaborating with you, asking you questions, how can we build it better? Strongly suggest checking out the EKS roadmap. We also, if you're just getting started with EKS or you want to go deeper, we have a number of resources that I highly suggest checking out. We have a best practices guide that goes through a fine-grained number of best practices to move into production and go at scale with EKS. It's regularly updated by our experts, including a number of the engineers on our team, as they find the best ways for customers to run and tune their clusters and applications. We have an EKS workshop that's training all the way from the 200 to the 400 level, and we're really excited. We're adding a new development workshop module for developers. So today the workshop covers platform owners, and we're going to add a module for developers. And then also we have EKS Blueprints, which is frameworks and examples for deploying complete clusters that works with Terraform and the AWS CDK. And I want to talk a little bit about development. So I know a lot of people are using Kubernetes. Some people are new to it. Some people are new to EKS and AWS. We have a new EKS learning path where you can expand knowledge and follow learning plans with Skill Builder. And you can actually have you or yourself earn EKS badges, which give you skills, and you can put on your social media, you can put on your resume, and you can actually be certified that you've achieved knowledge and that you've passed a number of certifications and qualifications for Amazon EKS. This is a new program that's launching this year from AWS. And we have the rest of re:Invent here. It's only Monday, can you believe it? So we have a number of really great talks if you want to learn more about EKS coming throughout the week. Platform engineering, the future of AI. We have a workshop on AI and how to build generative AI on EKS. We also have a deep dive talk on Carpenter and also a great talk on data processing at massive scale with Pinterest. Great. We're right at the end of time, so myself and my presenters, we will be outside if you want to grab us and ask some questions. And I really appreciate everybody coming today and sitting through our talk. Thank you very much.